In our yesterday session, we started understanding about how we are achieving the polymorphism in Java. So, and first thing is we understood compile time polymorphism or static polymorphism. So, why we are calling it as a compile time polymorphism? So, to achieve compile time polymorphism, what concept we required? That is all we discussed. So, the compile time polymorphism we are achieving always via method overloading. So the moment your methods are overloaded in a class, and whenever we are making a method calls, which method has to be executed, these are all things will be decided at compile time itself. And every time the moment you are calling the method by using that object, every time it will call same method. So that means the which method has to be executed, the decision is also happen at compile time level, and whenever you are executing the program also, the moment same method will be executed every time. So in this case, for example, if you are taking these two methods, these two method callings, so here it will take, in this case, this method will be called always because it is a integer value, it is a integer value, and it is a double value, it is a double value. The moment, for example, if I deleted this again, in this case, now what's happening with respect to these two method callings, this method will be executed every time. So because the reason is integer values are allowed by the double data type. So that's why in this case compiler decided like, okay, let's call this method like that. But whenever we are having a specific data type method with respect to overloading, then again compiler is deciding for this method, don't call this method and call this method. So like that, I mean, it's all the decision making, whatever the things we are defining at coding level or compilation level itself, things will be decided. And based on that only, at execution time also, things will execute always. So that is what we understood in the compile time polymorphism, or it is a static. So that means it's a fixed methods calling every time. Now when it comes to the runtime polymorphism, or we used to call it as a dynamic polymorphism also. So this is what little bit tricky, and this is requires some other points we have to understand, or some other points also we have to know about to understand the runtime polymorphism. So first of all, the moment runtime polymorphism coming into the picture, you have to understand two things. Runtime polymorphism is achieved always by using method overriding. So without overriding, there is no concept of runtime polymorphism. So that means the point method overriding. The moment method overriding coming into the picture means inheritance coming into the picture. So without inheritance, there is no method overriding again. So that means you have a concept of superclass, subclass, super and subclass points. So the moment whenever you are having superclass and subclass like nothing but inheritance relationship to make the method overriding, and by using overriding only we can achieve the dynamic polymorphism or runtime polymorphism. So whenever you are having inheritance in between two classes, generally we have a formula like a superclass reference can hold its subclass instance. That is class to class. Sometimes an interface can also refer its implemented class object. Its implemented class object. The most important fundamental uh, formulas or maybe rules, whatever you can think. Okay, so these two are very, 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 very important points. These two points will be, these two points will help you in every area going further, in every framework, every place you will see. So that much important these two things are, these two points are, please remember. And never ever forget these two rules or these two points. That much important these two things are. Okay, so because we will see same thing going further in our other upcoming concepts, frameworks, every way based on these two principles. And I said explained yesterday very clearly what is the point of superclass referring the subclass object or interface referring its implemented class object. So the moment I said superclass referring subclass object, it's nothing but, so here I have a class called as payment application and these are all child classes. So yeah, this one. Superclass reference of holding the subclass means the payment application is a superclass, and these are all child classes. So the moment whenever we have super and child class relationship, so whenever I created an object for the child class, I can refer with the parent. Why I referred everything with the payment application? Because for all these child classes, this is the parent. So that means for all these child class objects, I mean, whenever I created object for these classes by using new operator, I can refer that object by using parent class reference also. By using parent class reference also. Here what is happening? Here what is happening means you are referring directly with the same data type. The moment what you created object with same data type, same class name, you are referring the object. But here you are referring via parent reference, parent data type. But the object, real object is child object, nothing but credit card application class object. But you are referring with another class called as payment application, nothing but parent type. So that is what the formula, that is what the principle we have to understand. Same thing with respect to interface versus implemented class also, I said yesterday. So the moment whenever you are having an interface and its implemented classes, even interface can also refer interface can also refer its implemented class object. I'll take one small example about this right away. So that is what pending today, because the reason is yesterday we completed this polymorphism, dynamic polymorphism, how we are achieving. But anyway, I'll just remind you one more time. The most important, that's why I'm going again one more time. Okay. So, and how we are achieving dynamic polymorphism? Yesterday I started explaining you. Let's take a class called as payment application we taken, and it's all a simple base class, nothing but a super class point of view we taken. And from the payment class, I created three child classes. Okay, I created three child classes. And the moment I created three child classes, credit card, net banking, UPI payment, three child classes I have created. Not only child classes created, and I did one more thing also. What it is? I overridden one method called as make payment. You may override one or two, three, four also. It's up to your choice, or zero also. It's up to your choice based on the requirement point of view. But in my point of view, the moment whenever you are having method overriding, then only you can achieve the dynamic polymorphism. So that's the reason to understand the dynamic polymorphism point of view. What we did in every child class, we've overridden the method called as make payment. Make payment. So the make payment method is already available in the child. So that's why we are calling it as a method overriding. So we've overridden, we are overriding the method of make payment in every child class. So that means now make payment method is overridden by child classes. So based on that, what I did in the, when I am executing the program, when I am executing the program, if you observe here, and by using this principal point of view also, a superclass reference can hold subclass object, right? So yeah. So what we did based on that formula, based on that principle, superclass payment application, child class is credit card application. So please remember this relationship or these diagrams, that's more enough. So the moment, yeah, so the moment I created an object for credit card application class, the real object created for the credit card application, the real class internally, but it is referred by the parent. Actually, the real object belongs to the credit card class, but reference, only reference variable, the name given of by the reference of parent, but object, original object is not parent. In the JVM memory level, which object got created is credit card application got created. It's not a payment application class object. But what we did in this case, we referred first time with the parent type. Parent type. So object is credit card object. Reference is parent type called as payment application. So this is what the principle we followed. Now, in this case, I called after that by using that reference, I called a method called as make payment. So the moment I called make payment method is existed in the parent class as well as child class. So that means in this case it is a parent class, it is a child class, and make payment method is available inside the payment parent class level as well as child class level. So if you observe here, the make payment method is available inside parent, inside child also. Now which method is executed? So if you are referring credit card object with the same credit card class, then might be it will refer same thing. But the point here it is you refer this time with parent class. So that's why the method existed in the parent as well as child also. So then which method will be executed? So in this case, the method is executed always from the child class. The method executed from the child class. So the what will happen? Same thing. Internally Java will verify the method existed in the child class or not. The method existed in the child class or not. Internally Java will verify. Yes, available. So that's why what it will do, it will start executing. Yeah. So it will start executing from the child class point of view. So that's why yesterday we saw an output. This is called from the credit card application. But the reference is parent type. Okay, that is clear. And after that, what we did, we taken same reference again pointed to the UPI object. UPI object. So that means in the same main method level, what's happening? The reference we are shifted from the reference we are shifted from. Yeah. So the reference we removed from the credit class 2 where we given like a payment, please refer the UPI object. Please refer the UPI object like that we given the reference. So the moment we given UPI reference, what it does is it is removed reference from the child class point of view. I mean credit card object point of view. It is removed the reference. The references are gone from the credit card application and it is pointed to the UPI. So at a time one reference variable can point to one object. That point we know that in this case. So now it is pointed to UPI payment. And again I am calling the make payment method. Again I am calling the make payment method. So what is happens in this case is again it is calling from the UPI. So what we understood from this is yesterday is the moment parent reference is pointed to which child class object and that child class method is getting executed in this case. Instead of parent, it is always child class one existed. Now, my next question is, okay, let's understand and all this thing first. See here, first one called from the credit card class, second one from the UPI class, third one from the net banking class. So the method executed from the credit card class, UPI class, net banking class. But the reference point of view, polymorphism is saying what one object is doing multiple actions or one person is, one many formations. So one object with many formations. So if you observe here, it looks like one object. It looks like one object payment, but sometimes it is calling from the credit card, sometimes it is calling from the UPI payment, sometimes it is calling from the net banking application. Same reference, but depends on this scenario, depends on the situation, depends on the internal internal real uh, child class object. Based on that, it is making a call. It's not like every time fixed method is getting called, like from the parent or whatever it is. Sometimes credit card, sometimes UPI, sometimes net banking. Why? But internally, the reference pointed to which object, based on that, it is making a call. Now, my next question here it is, assume I have a method. Some method. Okay, let's go to the child classes only. Yeah. So here I have a method called as credit card payment. So this method is not a overridden method. It's not a overridden method. Why? Because this is not existed in the child parent class. So it's my own method. I mean, it is the own method of local method of the credit card application class, but it's not a overridden method. Why? Because same is not existed in the parent. So that's why I cannot call it as a overridden method. So in this case, the diagram comes like this. Okay. So what is the method name here? It is credit card payment. So it's not a overridden one. Now, can I call? I said dynamic polymorphism method overriding is important. Without method overriding, we cannot do the dynamic polymorphism point of view, right? So now, when it comes to this method, in our case, like nothing but not overridden method. It's a not overridden method. Now, by using same reference point of view, this is the reference we made, right? Yeah, this is the reference especially. So the moment I am calling payment dot make payment and whatever the method I called string point of view credit card and then some amount, it's okay, it is fine, that's what we understood. But now my point is, by using same reference, I'm calling a method called as credit card payment, and this belongs to which class? Credit card class. So this method is a child class method, and it's that too, it's not a overridden method. Okay, I have a scenario like this use case. So the first use case is when we are having overridden method. That's what about dynamic polymorphism. Second scenario is not a overridden method. That's what use case here it is. Not a overridden method. So now I am calling this method from the parent class reference. Same, just similar to make payment, I am calling this method. What is happening? Let's try to understand. Go to same class and point to, okay. So here I can point again to the child class also if you want. I mean, we can do one more time or we can create one more object also. Like see here. Now again what I'm doing is I'm creating one more child class object. I mean pay credit card application object, and I'm pointing to the credit card. So this time again my reference is again pointed back to the credit card application point of view. Okay, so I think you know all about these diagrams and all. Okay. Now what I am doing again, I created one more object, and again I pointed to this same parent reference is pointed to the credit card application. Okay. So this time I'm calling a method called as credit card payment, something like that, and it's not a overridden method. Let's see what happens. The moment you are calling make payment method, there is no issue. You saw like it is executing from where and all. Like again I'm giving some amount also here, whatever it is. So the moment you are calling last line, you will see it is calling from the credit card application. That is expected. So and it is a overridden method. But now I'm calling not overridden method. What's happening? See here. Payment dot payment dot, and the method name is what? Go to class directly. This one, right? Credit card payment selected, something, whatever it is. Okay. So this is the method, right? So I'm trying to call here. So see here, you're getting some compile time error. Compile time error. So what's happening? I'll try to tell you. Second scenario is second use case I'll take and then both I'll discuss at a time. So use case not a overridden method and method is from child class. That is what the important point we have to take. By default, overridden means its method existed in the child and parent. Okay, in this case, not a overridden method, but I taken method also from the child class. Now use case 2, I'll take. What is use case 2 is not overridden method, but method is from parent class. So that means what I will do, I'll go to my parent class called as payment application. Yeah, already I have one method called as get payment type, right? So it's a not a overridden method. So this is also not overridden by any child class. Not only, I mean, with respect to one class point of view, we have to talk not overridden by one of the child class or all of the child classes, whatever it is. So now if I'm taking get payment type method and if I'm going to the credit card class, it's not implemented. That means not overridden. Even from other classes also. But with respect to credit card class right now, it's not overridden. Maybe leave about other classes. Maybe they are overridden, whatever it is. But with respect to credit card point of view, this method is not overridden. So which method is not overridden means this method is not overridden. Not overridden. So that means you are not defined again same signature and you are not provided your own logic. That's why I cannot call it as a, it's not a overridden method and that it is from the parent point. Right? So now let's call this method. So that means the use case 2 is not a overridden method, but method is from the parent class. And that means the class parent class is this one and the method name is get payment type is the method. So this is what I'm calling. So same again I'm created object make payment wise no problem because it's a overridden method nothing but it is existed in the child and parent. And after that I called child class 1 which is not a overridden method and you got compile time error. So the result is what? Here the result is compile time error you got. So the moment you are calling not overridden method and that too method from the child class, you got the compile time error. Now, if you see here what's happening, get payment type like I will call. Yeah, if you see here, method of child class. Now, payment dot get payment type whatever it is, I'm able to call it. There is no compile time error. Method of parent class. Method of parent class. So that means at the moment there is no compile time error. You are able to make successful call. So that means the result is you can call successful. That means your program is compiled successfully. And that means you can execute also. It's nothing but you can execute also. So once executed compiled successfully means you can execute. But what is the problem here it is? So what you understood here it is. So that means whenever you are following this principle, again some rules you have to remember or some notes you have to remember that is what it is when we are using superclass holding subclass, superclass referring subclass object, okay, concept especially, and what we have to follow here it is when we are using superclass referring subclass object concept, what we have to follow is The method should be presented in parent class. The method should be presented in the parent class. The method should be presented in the parent class. So should be presented means what is the point of should be presented? If you go here, as per our explanation right now, make payment is the method is existed in the parent class. That's why I am able to call it. Credit card payment is not existed in the parent level. That's why you got the compile time error. Especially when you are referring child class object with the parent reference. Then only this rule applicable, guys. So, and that's why credit card point of view got an error. But right now I added one more method called as get payment type. Get payment type some method. Now this method is existed in the parent but not overridden. Overridden point of view, our examples are completed. There is no issue. And it is executing always based on the current object point of view. Now in this case, get payment type is the method. Get payment type is the method. And that get payment type method is not at all overridden by this child class or whatever it is. Especially talk about one child class. Same rules applicable for all other things. Now get payment method is not overridden by the child class. So in this case, I can see successfully program is compiled and program is going to be executed. But why here the problem is, this is what the thing. One thing you have to keep in our mind is when we are using superclass referring subclass object concept, so the method at the moment, whatever the methods you can call is, the method should be presented in the parent class. Should be presented in the parent class. Otherwise, you will get a compile time error. You will get a compile time error. Now, in this case, my next question is, then how can I call? Then how can I call credit card payment method? Then how can I call credit card payment? So here it is not allowing, right? So then how can I execute? Some reason this logic I want to execute or this method I have to execute. Then what I have to do? So then let's go with regular concept like create object on your own for that same class. It's all simply avoid this principle then when you want to call this. When you're following this principle, then that method should be presented in the parent class. So whether in the child class it is presented or not, it doesn't matter. So that means what you understood, guys, in this case, if method existed in both child and parent, then child class method is executed. Child class method executed like make payment point of view. So and then continuation to this note only. If method not existed in the child, that means existed in the parent point of view. So what I said right now, method should be presented in the parent, right? So if in case the method is existed in the child also, then child class method is executed. If method not existed in child class, then parent class method executed. Parent class method is going to be executed. So that is what happening here it is. Now see here, the point what from these three lines you have to understand very carefully. So overridden, that means available in the parent as well as child. So the moment it's available in the parent and child, priority given to the child. Second line, not available in the parent, available in the child. First of all, in the parent level there is no method and child level is available, but it's not allowing. So you are getting error. It's not the rule. What is our rule? The method should be presented in the parent. That's what. Now, when it comes to third one, it is available in the parent level and child level not available, but still you are able to execute it. In earlier case, both the places it is available but executed from the child class. Second scenario, parent class level, first of all, there is no method with that name. That's why, based on that principle, method should be presented in the parent. Otherwise, you cannot do that. So that's why you got error. Second point of yes, it is existed in the parent, not existed in the child. So that's why it is allowing and it is executing from the parent level. So that is what the point we have to understand here it is. So let's see here. Let me what comment that line and see what's output wise what's happening. See here credit card application. That means with respect to this, I think here you are getting some result string response whatever it is. See, this is what dynamic polymorphism point of view how it is achieving and all. So how objects are behaving. See, no payment selected. So that means this line came from where? From here. If it is credit card, it might have come on. So now the point is, if I want to, how can I call credit card payment in this case? Then create object directly for the, then refer credit card class object, then refer credit card payment application class instance with the same type. Nothing but equal to new. Yeah. Now you are not following that principle. When you are following that principle, and whenever you want to make sure the method is existed in the child and parent point of view, so you have to achieve that point. If so, your requirement is demanding like that, guys. If method existed in the child, execute from the child. If not existed, execute from the payment parent. Then what you have to do? Then 100% you have to go with this formula. So I will ask again two things here. The summary here it is. What it is requirement perspective. A requirement you got it like this. Define classes and make sure methods are executed if they are presented in parent class. Otherwise, don't allow. So this is what I said. So I said define classes with respect to inheritance point of view and make sure the method is existed in the parent, then only allow to execute method. Otherwise, don't allow it. So that means this is what I'm saying, right? So it is available in the parent, then only you're allowing to call that method. If not available, then you have, we have to make sure getting a compile time error. So that means then we have to make sure following this principle. That is one rule point. Maybe second requirement is like this. Define classes and make sure methods are executed if they are presented in the child, okay, or parent class. In a flow, I have to go like this. Then you don't need to follow that principle now. Now it's all about same class reference point of view. So you will apply this formula now. So that means same class reference is pointing to the same class object. So what will happen in this case? The moment you are taking same reference like this, go to diagram. Yeah. So here, now what you are doing, you are creating object for this class and referring with the same data type. So there is no principle of super subclass reference and all. So in such case, whenever you are calling this method, what it will do, guys? We understood earlier in the inheritance point of view. I said first it will look into the child class. The method existed or not is available. That's why this method will be executed now. Assume this is not existed, then it will go to the parent class and it will verify in the parent it is available or not. It is available in the parent or not. Yes. If it is available in the parent, then also it will execute when we are going with this formula. So now tell me, in this case, credit card dot this one, credit card payment, I'm calling, and as well as credit card dot, and I'm calling method of get payment type, which is really located in this super class level. Now tell me, now understand, these two lines are going to be compiled successfully or not. These two lines are going to be compiled successfully or not now. So in this case, what is the problem? I mean, what is the functionality will work in this case is this is what. So generally by default, what Java will do is internally, whenever you are having inheritance concept, whenever you created object of child class and referred by the same data type, you are not following that parent reference. You taken same child reference only. Child class object referred by the child class data type only. Same class data type. The moment you taken, I said one thing. First, it will check in the child class. If available, then execute. If not available, then check in parent. Check in parent. So they available, then execute it. And available, execute it. Even not available in parent, that means not existed in both child and parent, even not available in parent, then error. Then definitely you'll get the error. So there is no method existed like that. So that if you are taking this point of view, you're not following that principle and you're saying like credit card payment. It is available in the child class. So first priority given to the child class level, this method existed or not. Yeah, available. So that's why it is executed. Now when it comes to the next line, again it will apply same formula. Child class level, this method is existed or not. Not existed. This time child class level not existed. You are not overridden. Okay. So then what it will do? It will go and verify inside the parent class available or not. Yes, this time it is available. This method is existed in the parent class level. Then what it will happen? It will execute from the parent class. It will execute from the parent class. So that means if you taken this reference of same data type, then you can call your own methods, your parent methods also. But when your requirement is demanding whether existed in the child class, call the child class method, or else 100% you have to call only parent class method. So you have to restrict like that. Then you have to use this principle. Depends on requirement whether you have to go with this solution or whether you have to go with this solution. This solution. So your requirement is demanding the method should be okay existed in child class and parent, then only it has to execute. If not existed, parent methods has to be executed if not available. So that is how you, if you want to make a restriction means, then you have to define this point of view objects and references. Then 100% you will make sure only overridden methods got called, and if not, parent class. But in this case, even though parent level not available, you can call it. First priority given to the child only. If not available, then it will go to the parent. If you are going with this approach, whether it is right or wrong, see. So see here now, I'm able to call both the methods, but there actually this method belongs to this class and this method belongs to, if you see here, get payment type belongs to payment application. But why I am able to call this time? Earlier you are not able to do that when child class, but the reason is you taken this principle. You taken the principle of this one. Child class referring the subclass object. But here you define child class reference and you pointed to the same child class object, and reference also same only. That's why you can call your own methods child class method, as well as you can call parent class methods also. Like inheritance, a pure inheritance point of a regular inheritance. Child can access parent properties. It's a pure inheritance. But the moment you referred with the parent type, superclass type, then again this formula coming into the picture. This rule comes into the picture. Only the method should be presented in the parent. So then what is happening? If method existed in child also, parent and child, then child class. If not existed in child, then parent class method will be executed. But 100% is that method should be existed in the parent. After that, if it is available in child, then child will be executed. Priority given to the child. If child level not there, then parent class method is executed. If you are going with that formula. So depends on requirement. You have to take whether this kind of solution or this kind of solution. So that is what about the polymorphism. Okay, now second point is we discussed one point like in interfaces also, right? Like I said, every interface can refer interface data type can refer its implemented class instances, right? I said this point also. This is also one of the very important point. Now what I will do in this case is I will add a interface here, guys. So I'm adding an interface here, and I'll make implements relation here. So that means in the existing payment application class level, I'm going to add one more interface here. Okay, one more interface here. So the interface name I'll take like payment. And one abstract method I will take like make payment. And I'll take two string parameter. I mean, one is string parameter, one is double parameter. So what I'm doing is instead of taking a new example to prove that inheritance, I mean interface referring implemented class object, right? I'm not doing taking new example. I'm taking existing example only, and I'm making on top of, as of now we have parent and child classes, right? Now on parent level, I added a inheritance. I'm going to add a interface. And this is what will happen in this case. It implements payment. So the moment it is implementing the payment, what is the rule? You know, if it is an abstract method, it has to implement. But already in our Java logic, I mean in our class, we are already implemented. So assume it's implemented now. And child classes are overridden. So this is what a good example. So let's take an interface like new interface, and I'm taking payments. Okay, the moment I taken payments is a interface, and I will define one abstract method. Yeah, I'll take same signature so that we can feel like it is overridden in the child class. I mean implemented class. Yeah. So how many abstract methods I have means one abstract method I have. Now whatever the class is implementing this interface, that class must and should provide implementation to this. Now as per my requirement, what I'm doing, I'm taking this method, this class implements payment interface. Yes. Why I am not getting compiled error? You already did the overriding. So this is what overriding. This is what you did overriding. You did already method overriding. So that means with same signature you are having your own implementation, right? So that's why it's a method overriding only. You provided implementation. Implementation of interface abstract method. Okay, fine. So this is what the diagram is now. Now if you observe here, for all these three child classes, with respect to parent payment class, now for payment class point of view, one parent came payment. So one super class, super, I mean, I can say like in a simple terminology, I'm using parent and child. So now for this class, you got one parent. Maybe data type is a interface or class, leave it. In a inheritance point of view, child, parent, parent, parent. So like that. So that means now for these three child classes, now you got one more parent also. Along with existing parent, you got one more parent also. So same formula I will applicable. Now whenever the moment I said like interface can hold its implemented class object, the real point of view it's a implemented class object, implemented class. But this implemented class is having child classes of three more. So that means indirectly what you have to understand here it is. Now the payment interface can refer its immediate child, and the payment can refer its grandchilds also. I mean, like that. So it can refer these childs also. Why? These are all just in the point of inheritance. Why these three classes doesn't have direct contact with the payment or direct relation with the payment. In between that, these classes, parent class is having relationship with payment interface. So that's why these classes also nothing but directly or indirectly having relationship with the interface of payment. So that means now for these three classes also payment became a parent. This interface became as a parent. So that is what the point you have to understand. Okay, let's see here whether it is true or not. Go to the Swiggy application. Okay. So let's see here. What is our interface? Parent payment is the interface. Payments are payment. Yeah, payments is the interface, right? And for this, child class is payment application. I mean, child means implemented class. I said this is also one kind of inheritance only. Yesterday I said when you take an interface and class, if you observe, this is also one kind of inheritance only. That's why I used to say like that. One kind of inheritance only. This is the child. And for this again, you have three more childs. One, UPA payment, and second one is net banking payment. Total three. This is what the relation you have. Okay, fine. So now let's take same formula apply. Payment interface can refer its implemented class object. Point of view, interface is payments. Payment equal to. So it's an interface, guys. For interface, we cannot create the objects, but object created for the class of child. Sorry, implemented class. I am creating the object by using new operator. See, there is no compile time error. So that means this principle. So interface can refer its implemented class instance. Yes, I can refer this. Why? Because this is an implemented class for this interface. That's why you can do that. It's not like some other interface implemented class you cannot refer here. The relationship between these two are there. So that's why you can do this. Right. Now, similarly, I can do for these child classes after. Directly not implemented this interface, but in between them, there is a one more parent is there. So for this is a parent. For this is a parent. So nothing but for this point of view, now these are all childs only. We understood that. So that's why now see here payments. Okay, so even I can take same reference also. Payments equal to new credit card payment application. Similarly, same now the concept of what we discussed the diagram yesterday. I mean this one reference point of view, same thing will happen. Now if you are calling make payment method, from where and all it is executed, let's see here one by one. UPI payment and net banking payment. So total, see here, now with a reference interface point of view, I holded four objects. One time payment, one time this one time this one time this one. Now see payments dot make payment method I'm calling. Yeah. So see here now, again same principle came into the picture. Again same thing, this one. What it is? This one. When it is existed in the subclass, then call it, otherwise don't call it like that. Now see here which method is executed again. Concentrate only after this line. Credit card, credit card, credit card. Oh, okay. The reference variable is wrong variable. That's why you got this error. I also got surprised. Payment to payment option or whatever it is. Payment option. Reference variable, we use a wrong variable. Yeah. So now see, now let's execute it. Now if you observe here, what happened, see how the polymorphism is happened again. In this case, it called from the payment class. In this case, it called from the credit card. In this case, it called from the UPI payment. In this case, it called from the net banking class. But if you observe here, this is only one object, but called from different scenarios, different methods. Now what happened? Same method being called here. Four places are. That's what I said. That's why I given this arrow marks. Now the same payment referred with this child, this child, this child, this child also. Now, for example, I will break the relationship of that overriding integer x something like that, and I'll remove this override keyword. Okay. So now what's happened? See here. If you observe here, what happened now? In this case, the reference pointed to the credit card, but in the credit card you don't have this method signature. You have three parameterizer method, but you given two only. So in such case, what it is doing is it's verifying in the credit card with this signature method is available or not available. Then it went for this class any parent available or not. Yes, payment is available. So then it called from the payment. See here. So how Java is designed. So that means assume this method is not there. Instead of all this nonsense, I'll do like this. This method is not there. Now go to this Wiki application. So what's happening in this case? A pure inheritance relationship coming into the picture in this case. Why? So it's verifying in the child available or not. Child level available or not. I mean, especially this line level. It's not available. So that's why it is verifying in the parent level. Answer is no. So that's why it is moving to the parent level. See, parent class, payment class. But you pointed to the which child class object and you're calling the method. So it's not available in the child. That's why it went into for this class. What is the parent payment class? So that's why from there it is executed. If it is available in the child class, available executed from the child class. I don't know how you will remember all these scenarios and how much practice you will do. It's all comes with the practice. You have to make all these use cases and all. So then only you can understand all these things. Okay, so this is all about polymorphism, guys. See how one single object is making different behaviors, different scenarios dynamically. Why I am saying dynamically? See here, this time it is payment application, and the moment whenever I added a method here, and whenever I am executing same logic again, and if you observe here, this time it is again executed from the credit card application class. Earlier from the payment application class, now credit card application. So the things are happening dynamically while executing the while at the runtime level. So the JVM is taking a decision from which class it has to call the method, whether it is from the credit card class, whether it is payment class, based on the references point of view, it is taking a decision. So now what is the principle you understood here? It is interface can refer its implemented class object. So these two principles are very, 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 very important. Why means, let me show you one small example. Once you are done with your advanced Java, you'll start learning Spring, right? So I'll show you one small example. And not only here, it's everywhere. These two principles are most important. Everywhere, these two principles will be involved going further wherever you are learning anything newly. Okay, so this is all about the polymorphism. So what we will do is I'll stop the session right now. And if you see here, one small thing I'll show you. It is Spring Boot framework. Okay, if you observe here, what is this? Configurable application context I representing interface. I representing interface. So that means interface referring something means an object of some other thing. So the run method is returning internally some object, and that you are returning that you are referring by a interface. That means it it is returning somehow an implemented class object. This is one example, or I will show you one more also. Close project, open project. Yeah. So if you see here, this is Spring framework. Yeah. I think. These are all Spring only. Okay. Okay. Here I have Spring. That is all Spring Boot. I already shown you. Interface pointing to the some other object. So that's what the principle. Right now, what we learned. Interface holding some other implemented class object. So this is going to return some object that is referred by the interface reference. That is point number one. And I'll show you one more example also in the Spring framework point of view. So that is what why I am showing all these things is, if you are not understanding these things today clearly, and if you are not practicing things today clearly, then there is no then how will you understand upcoming topics like all these Spring Boot framework, Spring framework? Then you will not feel you are you will feel difficult when you are learning the upcoming topics. So that's why the moment when you are doing listening something, practice it. See, it's a Spring framework, for example, and yeah. See here, I did something. What is this? Annotation config application context, and reference is something. And the reference, if you observe here, I representing interface. Application context is an interface. Annotation context is a C represents class. Predefined classes only from the Spring framework. So that means the moment you created object for the class, you are referring to the interface. You are referring to the interface. So the same principle what we learned right now. An interface is holding its implemented class object. Yes, that means this class is implemented this interface. So that's why I am able to do this. So now today, if you are not understanding this concept, or maybe you forget the concept, don't say like not understanding, because I explained very well. And if you are forgetting this concept after few 1 week, 2 weeks without practicing, or somehow you are not doing the revision, then tomorrow when you are learning the Spring, when you are started learning the Spring framework or Spring Boot, whatever it is, not only Spring, Spring Boot, advanced Java also, even upcoming topics also, like collection framework, all this. So if you forget those principles, and if you are not practicing well, and you are not understanding very well without practicing, then how will you understand Spring and Spring Boot framework easily? The moment you practice very well everything today itself, and you remembered everything very well for the upcoming topics, then you will, the tomorrow when I am saying like, okay, I am taking an interface and I am holding with this object is holding by the interface reference, then you will understand easily. Oh, okay, this is already done in the core Java. It's all simple core Java only. So the namesake, it is a Spring Boot, but the original coding you are doing again in the regular core Java only. If you observe here, it is a regular core Java only. So frameworks will give some kind of abstraction solution, but not 100% uh, core level solutions. Core level solutions always written in the core mod, I mean core Java only. Please remember that point. So that much important core Java is. Okay. So we will see these are all things there also, but I'm just showing you to give you the boosting confidence and the need of learning today what we are discussing, whatever it is, whether you want to focus more or not. That's why I opened Spring Boot, Spring Framework, all this. Not only this, tomorrow, once we are done with encapsulation, probably I'll start exception handling or maybe collection framework, whatever it is. There also you will have this concept, superclass holding subclass object, interface holding implemented class object. Yes, collection framework. The entire collection framework will go with this formula. Interface referring its implemented class object. List equal to array list. Map equal to hash map. Like that. This principle is we will use most of the times. So that's why please go through these things. Take time, don't worry, and practice it. And we will see. And we will connect on Monday. Okay. And we have completed a principle of polymorphism. We are having pending of encapsulation, the four last one, encapsulation. But to understand the encapsulation, we have a small topic. Probably we are not discussed at right time, but I'll discuss Monday. First, this one, what it is access specifiers. So once we are understanding access specifiers, then then again we will discuss encapsulation. So encapsulation is very small topic and very straightforward only. But to understand the encapsulation, little bit we need access specifiers. So that's why I'll discuss access specifiers first on Monday, and then we will continue encapsulation also. Probably we can close both in same class. It's a very simple and small topic only. Okay, so that is what we let's connect on Monday, and please practice all these scenarios, whatever I explained with respect to all these interface, implemented classes, superclass, subclass, method overriding. Okay, method is not overridden, overridden method. So many use cases. We discussed a lot of use cases, and all are real-time use cases. And interview perspective also. Don't think like, see, simply tomorrow they will give these two classes, this diagram they will give. I'll ask same kind of questions. I'll give this diagram and I'll write these two lines in the below. And I'll ask what will happen. Can you explain me? So many people used to say like program will compile successfully. But no, program is going to fail. Compilation will fail in this case. And if I return this logic again, then this will. And again, I will ask these two lines. What will happen? So see one scenario, but lot of use cases. So compile time error executed, the reason is different. Executed, but the reason is different. So many lot of use cases comes and interview questions comes from this area. These are all interview questions only. Nothing but use cases are nothing but interview questions only. Okay, so they will ask simply like that, parent class level, child class level, different methods are there, and I called like this, what will happen? With this principle I called, what will happen? What is the rule? Then you have to tell them like compile time error you will get, and the rule is, this is what rule you have to tell in the interviews. And sometimes they will ask you also, what is the contract between super class? So the question is like this, what is contract between superclass and subclass if you want to achieve dynamic polymorphism, simply like this. If you want to achieve dynamic polymorphism, what is the contract you have to remember? So that means you have to tell this one then. Contract is nothing but if you want to achieve abstraction, I mean dynamic polymorphism, first of all method overriding, and especially this principle first we have to tell. Superclass can refer subclass object, and the moment superclass and subclass point of view, that method should be presented in the parent, and if it is existed in child also no problem, but priority given to the child. If not existed, given to the parent, but it's not existed in parent but available in child, then you will get the compile time error. So this is the contract we have to maintain like that. You have to explain all these points, and this is the interview question. And then immediately they will ask, no, 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 my requirement is I have a child class and their methods are there. I want to make sure methods executed from the child class, if not available from the parent. But my that is how I have to do that. Then you have to tell them, then don't we don't need to follow that principle. Simply define an object and assign with the same reference like this. Then in this case, what will happen if method existed in the child class, executed from the child class. If not available, then it is verifying the parent level. If parent level is, I mean, parent level is available, that's why it is executing from the parent. But in previous scenario, what happened? Available in the parent and child, executing from the child. If not available in the child, it is trying to execute from the parent, but not from the child. So small difference is there. Priority given to the child only, both the cases. But in this case, executed from the parent class always. And if you are calling child class method, it's not possible. But in this case, you can call your child class methods as well as parent class methods also. If you are going with this approach, you can call, that means in this case, what the summary you understood here it is, you can call child and parent class methods without any issues. Without any issues, you can call it. That is what the summary you understood here it is. But here you can call only parent class methods or common methods, overridden methods, but not child class methods. So in this point of view. So these are all details you have to remember. Okay, so let's connect on Monday and we will continue encapsulation or access specifiers we will see first and then encapsulation. Thanks to everyone. Let's connect on Monday.